So the way we do this is that we start with the Jacobi identity. So we know that the Jacobi identity is satisfied for a Lie algebra. So let's write that out. It's part of the definition of a Lie algebra, and for commutators, it's true. So this is the Jacobi identity. Now what we do is that we eliminate the commutator using our Lie algebra. If I do this, then in the next step, I get TA, comma, I, F, B, C, D, TD, plus TB, I, F, CA, D, TD, plus TC, comma, I, F, ABD, T of D equals to 0. And then we have again commutators of two Lie algebra elements. So I factor out, these are just numbers, I can factor those out. And the commutator of these two guys will give me another factor of I and time structure constant. So those I's will give me a minus sign. And then we have F, B, C, D, which is this thing. And then we have F, D, E, T of E. Similarly, second term, we have F, C, A, D, F, B, D, E, T of E. And then we have F, A, B, D, F, C, D, E, T of E is 0. Right? So, so we have an equation where we have this times E times TE is 0. So we have two choices. Either this thing is 0 or this thing is 0. And these are all linearly independent and they are not 0. So it must be that the coefficient is 0. So this means that we can write the thing as minus, let's just write this thing first, FADE, FBCD, and then minus, let's write this guy first, FBDE, and this guy, F. But when I write this, let me just exchange these two indices and write and change the sign here. So I get ACD. And then what I do is that I can take this thing to the other side. So I get a plus F ABD. And then let me write F as, instead of CD, let me write this as DC. If I DCE, if I do that, then I have to change the sign to a minus sign. Okay. And now what we do is that we go and look at our definition of F. And our definition of F was here. So if I look at my definition of F and I come back, I get two factors of I, which get rid of the minus sign. We get the matrix FA. It's DE element multiplying the matrix FB. Sorry, it should be Hang on. Yeah, sorry. So we basically get, yeah. So this thing is f of b, it's CD element, and this guy, it's f of a, DE element, and then we have a minus sign. We have f of a, it's CD element, this is this thing. Then f of, I didn't need to really change the ordering before, I just realized that. F of B, DE element. And on the right-hand side, the -1 becomes I squared, and I keep one of the i's, and then I get a minus I, which I then F, A, B, D, that minus I gets absorbed into this thing, which becomes F of D, CE. And so if I multiply everything by a minus sign, I get FA, commutator of FA and FB, and we are taking its CD element, and here is IFABC, AB, ABD, AB, let's call it E. E, we get FE here, it's CD element. So now we can get rid of the indices of the matrices, then this equation becomes commutator of FA and FB is equal to I, F of AB, C. This is a dummy index, so I can change it, F of C. So thus we see that the prescription that F of A, B, C is minus I, F, A, B, C does satisfy the Lie algebra. And therefore, this is a bona fide representation. Okay, any questions? I mean, this is just a do yourself. You have to repeat.
I have a question about the second to last line.
Yeah.
What did you do when you swapped the E's for the D's, something like that?
Oh, from here
Yeah.
to here?
Did you swap the E's and the D's?
Let's see what I did. Yeah, so here the free indices are C and E, right?
Yeah.
C and E. And so we have to, I mean, they're not summed over, so they have to be. So yeah, what I did is I just relabeled them. When I came to this, I should have used E, but I just used D instead.
Okay, I see.
Yeah, so I have to use, wherever I had E, I have to use D. But of course, I cannot use D twice, right? So I changed that back to E. So these are kind of the index sort of, manipulations that you do when you have done this for like 20 years, 20, 30 years, and you just don't even think about it. But you're right, if I were to be careful and not confuse students, I should have, coming to this line, I should have used an E here. And I should have used an E here. And I should have used a D here. Okay? And then coming here, we are just getting, we are just suppressing these indices. Okay?
Yeah, makes sense.
Yeah, you can call this D as well, but since it's summed over, it's a dummy index, so I can call it whatever. Okay, any questions?